So let's continue our tutorial, practical tutorial, and this video is dedicated to calculation of water indexes, normalized difference water index and modified normalized difference water index. So at first let's create data frame and name it normalized difference water index, and also add group of layers for 2016 and 2020. So at first let's calculate for 2016, right? So it's group of bands. Again, go to raster calculator and let's use first float. So this is a index of normalized difference water index, formula green minus near, green plus near infrared. So for green is our second band for Landsat 8, right? So it's band 3. So band 3 minus band, this is one is red and this one is near infrared, and we divide into, again, use float, green plus near infrared. So so I will click OK here, and you will have this image, normalized difference water index image. So this white areas represent water bodies, see, water bodies, and these dark areas represent no water, and this is something in the middle, gray, right? So it can be probably more water, probably some water content, probably some moisture, but true water body is this areas. Do this, repeat the same step for 2020 using raster calculator. So the value should be from -1 to 1, and let's at first research our image, NDWI. So let's research water areas. So see, values are from 0.17, 0.16, so above 0. So this is 0.22, etc. This is also 22, and these areas are also can be considered as water. 90, 80, this one is 10, this is also water. $12, 10. Let's check this. I think it's close to 0, 1, 25. So you see that no pixel is even close to 0.5. So this is all considered as water. So we should remember that values, let's check, just not pure water but close to water, probably this one, right? So this is irrigated agriculture areas, 0.15, 11, 10, etc. So we can consider that values above 0.1, right, can be considered as water content, bodies that have water content. So this all values even less than 0.1, probably we should research again. So this is also irrigated agriculture. It's not pure water, but it has a lot of water content. So probably even this is less than it's less than 0, which is strange. .5. So it's also can be considered as water. 2000. So let's check this lake. See that this value range is smaller, probably due to atmospheric effect or due to the sun elevation also. So the important thing is that in order to do more precise and correct change detection analysis, you should also apply radiometric and atmospheric correction for image before doing this analysis. So let's go to symbology, classified, 3. No, actually it's even 2 classes are enough. So I can put here above 0. Close to 5 probably. This one. So this is water and this is non-water. Let's click OK. It's dark. So this is water, see, and non-water, and we can save the symbology. Save the symbology to new folder, classified RFD, and import the symbology. New folder, no. Save as LAR file, sorry. NDWI 2020, NDWI actually. Let's go to again and import NDWI 2020. So the same value, the same color. You can compare a little bit difference, and we can reclassify. Them, convert from continuous to discrete, two values. So this is, yes, no, actually it's showing from minus to 0.5. It should be not minus but plus, and let's take 0.4, right? 54. So okay, and this is for 2016, and do the same with 2020. So the first one is already reclassified, and now we do the same with 2020. It's not minus but 54. Okay, class NDWI 2016, 2000. So these are my 2020. So these are my 2 images classified. Let's calculate area. Field calculator, count multiplied 900, close the brackets, and divide into 10,000, which is in hectares. Do the same for this image. add field area long integer field calculator, multiply to 900, close the brackets and divide into 10,000. So this is for 2016, this is for 2020. We can compare. Actually the difference is very small, but we should remember that in order to do more precise and accurate correction, accurate change detection analysis, you should apply both radiometric and atmospheric correction to eliminate the effect of sun elevation, also probably a small effect of the distance from Earth to Sun the day during the day of the footage, and what else? That's almost it. While for atmospheric correction, it's also you should be on a clear day without any effect of atmospheric gases, etc. And also it is better to do download more the satellite image with a higher spatial resolution, for instance Sentinel. In this case you can do more precise change detection analysis. Anyway, the values are very close to each other, very close. See, but in 2016 it probably was a little bit more water, and also it depends on the time of footage, the season and the month, because the first one, the difference is that 2016 image was taken in the mid of September, and this was at the end of August. So the difference is almost 2 weeks, but we don't know for sure whether it really influenced it, because the rainy day also started. Probably this is also effect to the some area and level of water in mountains, probably, etc., in rivers, etc. So, and let's do the same with the modified normal difference water index. So spatial analysis, raster calculator, to calculate modified different and normalized difference water index, we should use now shortwave infrared except of near infrared. So again, use the float, and for 2016 green minus shortwave infrared 1, this is the band 6, right? Because near infrared 1 is band 5. Again, band green plus shortwave infrared band 6. This is there, it shows that there is some error. I didn't divide it here. So modified normalized difference water index for 2016. So do the same thing for both 2020 and 2060. So I already calculated it. So also values here from -1 till 1, and we can also check, make some research. I can close this one. Let's check. So values for 2020 for water bodies above this one is more than 120. We can check these areas. Whoa, it's even higher. This one are irrigated agriculture, so values are relatively high. I can check this one again, irrigated agriculture, so almost close to 120, 0.20, sorry. Probably last check of these areas. yeah, and do the same with the other year. So the values are the same. So let's open two areas, and we can see here we can change here visible layers, so it will choose both of modified NDWI, and for 2016-20, see the pixel values are different, small difference, because of the different sun elevation. Also, this place is really differs. I don't know why. Water area. So these are close. These are really differ. The reason is it's hard for me to. So see that in this 2020, these areas are not water. So also the season and the day also influence to water content, because probably as I mentioned that 2016 is the mid of September, this is the late of August, probably this was a rainy day, and also probably some water was used for agriculture. See that all our surrounding areas are agriculture. So anyway, the values are close, and we can also check the values for no water. See, minus, all minus, and we can check also for urban. This one is urban. All of them are minus, except water areas. So this one is water. See? So okay, and let's again reclassify 2016, go to classify, again choose two classes, and we can choose here from 0.15, right? So this is non-water, this is water. Click OK, reclassify 16, and do the same for 2020. Uh, 15, right? Okay, and 2020. So my images are reclassified, so I can close this. So I have both for 2020 and so let's make it gray, and let's make it blue for both years. Again, let's make it gray, let's make it blue, and I can check, I can calculate now. See the very precise actually detection of water bodies. So area, long integer again. So as you may notice that MNDWI modified water index have a little bit higher values for water pixels comparing to just a conventional water index. Okay, so I calculated for both areas in hectares. So these are non-water, these are water. So we can compare. The difference is not very huge, but actually we can compare that in 2016 there was a little bit more larger area of water cover, 46,000 hectares, compared to 2016. These are approximately 44,000 hectares. I will finish the video here, tutorial. So we both used a normalized difference water index and a modified normalized difference water index. There are some slight differences between them, and it's up to you to use which one index is more suitable to your study area. I will actually prefer modified normalized difference water index because in shortwave infrared water has no reflectance, therefore it elicits water areas more precisely. So I will stop the video here, and as the end of practical tutorial for water indices.